I think I have a new seating chart. Hold on.
Oh my god.
A new one? It's because we're
And I
all...
think it solves that issue.
I got it!
Hey. Okay, we get it. Pick seats and keep winning.
All right. You were supposed to be. Did you guys just flop? Is that all you did?
Me?
Yeah. Did you switch with Sloffer? Is that all you did just
Stole
now?
my seat.
Well, I just figured I was working.
He just
Oh,
thought
gotcha. Because you were supposed to be sitting behind Sloffer. That's where you're supposed to
Taking
be.
my things, don't you have my consent?
All right. Go ahead.
Well, you can work.
You may begin.
No, you can't have
Well, I'm not gonna move.
Playing game.
Great.
What are we doing?
You're behind the
Oh,
hell.
my goodness. Can I see your...
Behind who?
Dave, work with Kate, and he'll tell you what you need to do.
I'm not working.
Song of the day is Triangle. Get it?
No, I don't.
My bad, bad, not good.
What in the world?
I'll give you a couple songs.
This is poker music.
Step and play.
Here's the example for double A, double B.
Thank you.
Okay?
This is my jam. Oh, wait.
I love some slow music. Sounds great.
Yes.
What go?
That's pretty good that you're missing. So,
This one is soup.
you have double A. Right, but there's no like you can add single A or have double A half or triple A half, right?
I'm done.
That's pretty good. You also accommodate single A and you have A half. You have A half. You have A half after that, just saying.
Just let them burn.
There's more.
What if I take an ad? Mac, who is this?
Bad, bad, not good. It's just not bad. But also not good. Notice how when we have an A and a B, we can have just a single A and a single B together, right? So you don't have to always use all 6 letters. Okay, so make sure you get those 6. Making a flowchart like that is a really easy way to make sure you get all of this. Well, when we move to the left, we had an A. When we move to the right, we had an S, right? Well, you started at A. Then you moved to the right, and you got A. Kenna! Yeah, so I think not a better way to make
We don't have a good relationship because I've been so obnoxious.
I don't want to do this
Make sure you start with single A and single S.
I did. I'm writing these down.
Sorry.
Math. Yes. I think I did it. I don't know if I did it. But
Second.
Yeah, I think so. Whoa. How do I get the third? Wait, if I go up one more, that get the third, right?
there's like so many different ones. Yeah, it's fine.
Hey.
Like,
Can't stand 2 words. Can't stand. Well, if there were, and when I have friends at my house, I would not let them go to my last one.
Oh, the I
House. That'd be part of the welcoming show.
I'll give you one more bad, bad, not good song to work on this. Time moves slow.
No, Alex, no. Jared right now. What? Where's that like? Oh,
Really important.
slimy.
Need a little bit more, guys. Come on. step is another way to write that.
Oh.
Right. SAA doesn't count. It's the same thing forward and backwards. Okay. Find all the other ones.
Lori, did you do the weird way?
No one doesn't like it.
What do you mean the weird way? The fancy way. It's not that hard. Just a bit. See, you add another S that way, you add another A that way. So that would be AS, that would be AS. You're adding another S, you're adding an S again. Just add more S's that way, add more A's that way.
Write down what you have.
You don't have to write that. Jenna, you're doing a great job.
Everyone today has told me that I'm looking like I'm trying to do that.
No, I was just wondering why you're not doing anything yet.
I don't know what I'm doing.
Okay, well, let me know. You're gonna let me know.
I don't know either. Okay.
So, you're gonna start with regular A and regular S, right? I give you the example for double A, double B. And you're going to write all the different combinations that you can do with A's and S's. So, for instance, to start, and to keep track of what I'm doing to show all the combinations, whenever I move left, I'm going to add an A. Whenever I move right, I'm going to add an S. So if I move to the right from here, that's going to give me AS, which is the same thing as moving to the left from here. If I move left here, that gets me double A. And if I move left again, that gets me triple A, right? And now I'm out of A, so I can't move to the left anymore. Same thing here. Jenna. Yes, you may. Haley. I'm saying for my diagram, whenever I head to the left, that's adding an A. And whenever I head to the right, that's adding an S. Well, I added an S each time this way. This way I added an A.
So how do you get
Oh.
I can add an A here. And I can add an S here. There is. Turns out if I add an S here, that gets me the same thing, right? If I add an A here, it gets me the same thing. We're going to go all the way until we have 3 A's and 3 S's. That's all you have to play with, is those 3 A's and 3 S's. So that's the start. Yeah, you have 3 A's and 1 S, yep.
We're trying to get what?
You have a maximum of 3 A's and 3 S's. You're trying to show all different things you can do out. Right? A single A, a single S, one of each, 2 of one of the other.
Doing that over and over again.
Yeah, pretty much. Yeah, and it'll give you all the possible combinations of things in there.
Yeah, are we taking a food test for this semester?
No. What?
I had a question on this.
Yeah.
So, say I wanted to move this left.
Yeah, another A. Yeah. Alright, so I think you guys are starting to get the idea. For the most part, if you're not,
I got
watch
it.
now so you can see. So what we call this is a tree diagram. When we have 2 options, we can make it into a left or right tree. If we have 3 options, obviously we need 3-dimensional space, which isn't very easy to do on a piece of paper. But this is going to show all the different combinations we can do. So we can't go left anymore from here because that would be adding another A, and that would be 4 A's, and we only have 3 to work with.
Touchdown, baby.
So we only can go right. If we do that, that's going to be 3 A's and 1 S. Which is the same thing as going left from here, because that would add a single A. I go right from here, that's adding an S, which would be the same thing as this.
ASS.
Double A, double S. This adds an A if I move to the left. This adds an S if I move to the right, which gives me the same thing. Double A, double S.
Okay.
Here, these will match. I'm going to add an an S in this direction and an A in that direction, which gets us this. 3 S's and 1 A. These will combine. So I'm adding an A from here. That'll give me 3 A's and 2 S's. Which you'll notice is the same thing as if I started here and added just an S, right? 3 A's and 2 S's. Over here, if I add an S, I get 3 S's, and I already have 2 A's.
Someone let Jen. She's just.
Oh, so you had to add the A's because you ran out of S's?
Yeah, I have 2 A's and 2 S's here. So if I move to the right, that means add an S. Added an S, right? What you'll notice is the same thing if I started here and added an A.
But if you wanted to, couldn't you do it one more time and add the extra A?
I can't, and that gets me to here.
Oh, okay. It's like a factor tree.
It is, pretty much, yeah.
Sit up there.
Now that's not all, because there are other ways to write these. So for instance, AAS could be written as ASA, right?
Angle side angle.
Something like that, yeah. And ASS could be written as SAS.
No, I do
Because
not.
that's only 2 ways to write those, though.
Dude, that's not what I mean.
That's so weird.
Shut the hell up. That's not what I mean.
That's a good idea, Schwaffer. Take your own advice. All right.
That's not what I mean.
Such a weird.
You're such an owl.
Only 2 ways to write that. If I wrote SAA, it would just be this guy backwards, so I'm not going to count that as a separate way of writing it. Lots of ways to write this one and the above. I'm not going to worry about that right now, but I think you can see how there's lots of different combinations here.
I got it.
So that's one way to write a tree, which is kind of neat in itself. What it ties into today is triangles. So before, last semester, we were proving congruency between like segments. So to prove that this segment's congruent to another one, all we have to do is say that this segment and this segment are the same length, and because they're the same length, they are congruent, right? That's all segments have going for them is their length. So if they are the same length, they're going to be congruent. No big deal. Last semester, we also said that if we have 2 angles that are the same measure, then they're congruent as well, right? So these 2 angles are squeezed as much as they can without popping apart. These 2 angles are going to be congruent because they're the same measure. Today we're going to be proving triangles congruent. We're going to start dipping our toes into that a little bit.
Whoa.
Nope.
Now triangles are more complex than angles and segments because segments only have length and angles only have measure. But a triangle has 3 angles and 3 segments. So we have to check to see if all of them are the same. So for a triangle to be congruent to another triangle, like this triangle right here, for this triangle to be congruent to this triangle, that means all the sides and all the angles have to be congruent. What I mean by that is not that all of these sides have to be the same, because obviously they aren't, right? These 2 are longer than this one. What I mean is that the corresponding sides, remember corresponding means same relative location, right? The corresponding sides have to be congruent. And they are. Same thing with the corresponding angles. Corresponding angles are angles in the same relative spot, right? So left side here, right side here are corresponding. These 2 angles are corresponding, and these 2 angles are corresponding. And they are the same angles. You can check by putting the triangles on top of each other. So not only are all the angles corresponding, but so are the sides. And if all the sides and all the corresponding angles are congruent, then the triangles themselves are congruent. So this is a lot of things to check, right? If we wanted to check 2 triangles to see if they're congruent, we would have to measure every single side, make sure they measured the same. Then we'd have to check every angle, right, to make sure they're the same. It's a pain in the butt, right? A pain in the ass, right? So the question is, do we have to check all of those? And if not, what's the minimum number of things we have to check? So for instance, if it turns out if we only need to check one side for all the triangles to be congruent, for all of them to be congruent, then anything that already has a single S in it works too, right? It's just extra information. So it'd be really nice if we just had to check one side, because that means we wouldn't have to check any of the rest of the stuff, we'd be good to go. Now we know, just because they have one side the same, doesn't mean they're going to be the same triangle. For instance, this triangle and this triangle have one side that are the same, right? So they have one side that's shared. But are they congruent? No, they're not. So one side isn't enough to call it congruent. Here's an example of when that doesn't work, right? So one side's not going to be good enough. So let's check the next thing. What if we know two sides are congruent? Is that enough to say the triangles are the same? Well, here are two sides that are congruent. But are the triangles congruent? No, they aren't, right? So that's not enough. What about all three sides? Remember, the angles and the sides have to all be the same. Well, here's the deal. I want to try and make a counterexample to show that they're not congruent, but the only way I can make this triangle is to do it like this. And if I don't do it like that, the angle's different, it ends up not connecting. So it has to be this way. If all three sides are locked in to be the same, these, and these, then the angles get locked in as well. Which means if I know all three sides are corresponding, then I know the triangles are congruent. Yes?
But like what, I don't know how to say it, like if let's say one is 8 long on the orange, let's say one's 8 and the other is 4. I don't know, isn't there a way that can be like congruent to scale or something like that?
Yes, they can be similar. That's something we'll talk about later. Right now we're worried about exactly the same. Later we'll be talking about something that they're similar. They're not quite the same size, but they're basically the same thing, right? So right now we need exactly the same. All sides matching, and by all sides I don't mean all the sides of the same length, because obviously they aren't, right? This one's longer than this one. What I mean is that the corresponding sides, the sides that match up, need to be the same as each other. The corresponding angles, this angle right here, that angle right there, and that angle right there are corresponding, right? So that, and that should be these two. Oh, I'm sorry, these two, and these two should be equal. And if they are, then the triangles are congruent. So we've shown that we don't need to check all the angles, we can just check all three sides. And if all three sides match, then the triangles are good. What about this side of the tree?
No.
If I know one angle to be congruent, here's an angle. Ugh. Here's an angle. And here's an angle. These are the same angle because I can put them on top of each other and check. Also, that's as small of an angle as I can make with these. Ugh. Strong magnets. So these angles are both the same. Is that enough to prove that whatever is left over for the triangle will be the same? Now be careful. Why is it not? So offer you want to make me two triangles that have the same angles here and here, but are different lengths that are not congruent? So, can you make me two triangles that have the same angle here, but aren't congruent?
No.
How would you do it? Can anybody do it?
I think it's, I don't know, it doesn't seem possible. I think it is.
Now remember, all we're talking about is the angle measure here. We're not talking about these lengths.
I can do it.
Yeah, tell me what I need to do.
You need to make the left side longer,
Okay?
like, I don't know,
So if I were to add on one to here,
yeah.
okay, still the same angle, right? Check it out, still the same angle. Doesn't matter how long they are. All we said was we're checking for one angle being the same. And then connect them?
Yeah.
Okay.
That
Yeah.
would be similar, right?
So these two angles need to be the same. Shh.
Like just,
I see what you're doing. Okay, so you wanted me to do this. Come on, magnets. I had trouble with these all day today.
maggots, Rain Man, is that his name? SpongeBob would throw his head everywhere.
So I have this angle the same
Yeah.
as this one. And I extend this out.
was just gonna say connect those right there.
How so? You want to come up here and do it?
Yeah.
Okay.
Sure. But can you make that one the way it was?
Yeah, I can set back.
Make it better.
Yeah, good. It's not near. Alright. Make sure these two angles are the same. And make the triangles different
I was
sizes.
gonna ask you what you did to make the one big one. Didn't you like, you know what I'm saying? I mean, the big one and then you didn't do this one yet, you know what I'm saying?
Make a new one.
Check this out. Check this out. Whoa, it's not a triangle. Wait. There we go.
Big element?
Is that a triangle, right?
That's a triangle.
Consent, yeah.
So,
Or you could just
you were
scribble
saying
out.
these angles have to be the same?
Yep.
That's
Can you make another
obvious.
triangle that has the same
Well,
angle
big
as
L was
that
there
one
for
you
me,
just
no,
made?
wait. Of course you were all.
But it's a
That
different
one
size.
right there.
Yeah, make another triangle that's a different size but with the same angle.
It's a different size? Alright. So look, hear me out.
Hear me out.
Yeah.
Well, that's one way of doing it.
Holy Jackson, this is huge. Wow.
So she said,
Oh, wow.
so you missed
Yeah.
my, whoa, that's not a triangle. That's a triangle, you agree?
Yeah, that's fine.
It's a different size than this, but
They have the same left angle.
yeah.
Yeah, well done. Alright, so that's one way of doing it.
Congruence.
Are these triangles congruent? No way, right? They're not the same size. One is bigger than the other. But these bottom angles, these angles are the same. So having one angle the same is not enough to show that the triangles will always be the same, right? One angle is not enough. Probably not very surprising. What if two angles are the same?
It has to be congruent.
What are you?
It is congruent, I know
These
that.
two angles are basically the same down here. But are they the same triangle?
No.
No, they're not. So that's not enough either. What if all three angles are the same?
Yes. Pretty sure.
Here's an equilateral triangle. That means every angle here is 60, right?
60? Oh,
These angles are the same. Check it out. Same angle. Same angle. Same angle. Yeah, I am, aren't I? Right? So the angles are all the same, but are the triangles congruent?
No.
No, they're not. So even knowing all three angles match up is not enough to prove they're congruent. Turns out the angles don't lock in the sides, but the sides do lock in the angles. If I know the three sides, no matter what the side lengths are, as long as they correspond, it locks in what the angles have to be. It makes the triangles congruent. But just because the angles match doesn't mean the rest of the triangle will. You guys see the difference there? So triple side matching up is enough to prove it congruent. Triple angle is not. Doesn't work.
What about triple angle and triple side?
Triple angle and triple side, well, by definition it would be because everything would match then, right? All the angles and all the sides. So we want to try, we know this definitely works. We want to try and cut out some of this, right? We don't want to have to check all of that
Cut out
every
one A,
single
cut
time,
out one S.
right? So we know all the sides, we're good to go. We don't have to check the rest of the angles. What if we know one angle and one side? The way I'm going to check that is this.
X
And you guys are going to do this in a second, so make sure you're paying attention.
plus 2x plus 60 equals 180.
So I'm going to draw instead of mess with these things because these things kind of are annoying. So I'm going to make a side of 4 for both my triangles. So that way they have one side matching. I'm checking side angle. If I know one side of each matches and one angle of each matches, does that mean the triangles will match, right? Give me an angle.
98.
All right, so I'm going to make an easier one than 98. Come on.
28. 90.
30 it is. All right, so in order to make a 30-degree angle, what you do is you take your protractor, put your circle on one of the endpoints, okay? And then the line that's going to make one of your angle, or the line that's a half of your angle is going to go on this line right here. So I line those up, and then I find 30 degrees, which is what Schloffer asked me to make. And I'm going to put a dot there,
And draw.
and then I draw it. Now notice I don't care how long this line is because only one side has to match, right? So I'm just going to draw whatever. key is that this is 30 degrees. I need that for both.
I got it, don't worry about it. Oh.
Let me draw a 30-degree angle over here.
Hey,
I will kill you.
I heard a bad word.
Yeah.
Now watch.
I will kill you.
Whoa.
Instead of drawing this all the way through like I did that one, I'm going to make this one shorter on purpose. But it's still 30 degrees. So we have a side matching and an angle matching. But as you can see, does that mean the triangles will definitely match? No. Here's an example of a triangle that has the same side and angle. And here's an example of a triangle that has the same side and angle. Are they the same triangle?
No.
Definitely not. So side angle is not enough to prove it. What I want you to do now is try the rest of these. We're not going to try every single one because eventually we're going to learn that some are already good. For instance, we know triple side works. So I already know that that works, right? I have triple side plus extra info.
I love it.
Same thing here. So that all works. Now, notice that there's a difference between double AS and ASA. You have to check those separately. What double AS means is that you have two triangles with matching angles and a matching side in between. That is ASA. That's different from double AS. Double AS is this. We have A, and then a side. Does everybody see the difference between ASA, angle, side, angle, and angle, angle, side? It's the order that matters, okay? So some of these will work and some of them will not. I want you to check that now with a piece of paper. So go get your protractor if you don't have one already. You should, I gave you one. Go get a piece of graph paper and try this out. So what I would do first is I'd make a line that I'm going to make the same for both of these. And then I'd make two angles and see if I can make two different triangles. We're trying to prove this false. Get started on it. I will walk around and help you. I know it's new and weird. Yes.
Like for that bottom one where it was angling the side, is the side on the hypotenuse?
It's only the hypotenuse if it's a 90-degree
I
triangle.
just heard something. Really?
That is impressive.
Some squiggles. Well, I did the squiggles and then I erased some of it. And so I
Put
put
it in the back.
Okay.
I'm just like,
That's how I
shut
draw.
up, man.
Go get a piece of graph paper.
I squiggle on a piece of paper and
Oh,
then
you
I
said
draw.
back of this?
Squiggle looks
Graph
like.
paper. We're down to
Very
warm up.
creative. What did you do in first?
It's kind of weird. Stick with it. It's weird.
What does math have to do?
It's just going to be weird the first couple days.
What happened to
Will.
your fingy?
Why can't math be just simple? You know, 1 plus 1. There you go.
Your other fingy. Your canuncle. Yeah, what happened?
Probably cutting this.
Ah! You're not a vegetable Mac?
So I have three.
So check out the chart. Which one do you guys want to check together? We'll do one
Three
together.
angles and two
Not
sides.
that any of them help.
Well, let's check
ASS.
earlier stuff because we do this one, right? That's inefficient. Dykema, look at me. Put that away.
I'm sorry, it was good.
I like to
Okay?
complain that.
So check it out. If we check this one, that's inefficient because if we check this one and it's right, then this one we get for free. See how it already has two angles and a side in it?
Oh.
So we want to check the stuff lower down first because then we can get a bunch for free like we did here. See how it already has 3 S's? So let's check angle, side, angle. Let's check this one right here. So the way I would check that is I would want two angles with the side in between matching.
What in the world?
So here's the side that's 5 in length, and here's the side that's 5 in length. So we already have our sides matching, and then we need an angle on either side that matches. So what I'm going to do is I'm going to take out my protractor. All right, Kayla, we're going to check angle, side, angle to see if this is enough to prove the triangles have to be the same. So what we're going to do is try to find an instance where the angles match up and the sides match up, but the triangles aren't the same. If we can find that, then we know this doesn't work. If we can't find that, we know it does work. Okay? So I need a side in the middle that's the same for both my triangles. There's my side I'm going to start with. I chose 5 because I did. Okay? And I need 2 angles on either side that are going to match up. After that, everything else is free. So, give me an angle to go from here. Haley.
30.
30, all right.
We're stuck on the 30 card.
We are. So there's 30. Again, doesn't matter how long it is. I just want the angle. I'm going to do 30 over here as well.
Oh, wait. Oh, that's not even right. There we go.
Those are both 30. Give me another angle.
50.
50, all right. So I'm going to the left this time, which means I need to look up here. I know it says 130 there, but that's just has to do with linear pair theorem, right? 50 and 130 makes 180.
LPT.
Right, if we count from this way, it's a 50-degree angle. If we count from this way, it's a 130.
That's LPT right there.
So there's 50.
Wait, why are we doing that?
There's 50. I'm going to do 50 over here as well. And I think you'll see very quickly, like Haley was saying,
What the hell?
it kind of forces your intersection, doesn't it? Are those 2 triangles congruent? Yeah, they're the exact same thing. So it turns out knowing angle, side, angle is enough to prove the rest of the triangle congruent. It kind of locks it in, doesn't it?
Sure.
Isn't it a postulate? Or no?
Isn't that a box?
Isn't it what?
Isn't it a postulate?
A postulate? It is. We are accepting it to be true without proof. It just has to be, right? There's no good way of proving it other than just being like, we can't find a way to disprove it, so we're going to accept it on faith. Depending on which geometry you're following, like Euclid's geometry or a different person's geometry, there are rules and what they start with as postulates. These might be theorems. In our class, they're going to be postulates. We're going to accept them true without proof. And then from there, we're going to build the rest. Okay?
Are they true?
That is official.
They are true.
Okay.
That is official, right?
No.
Yep, it works. So ASA works.
Go back to the
So ASA does work. Does AAS work? Let's check that one together. So AAS would be this, where we have 2 angles and then a side over on the side, right? So let's set up our side. Here again, I'll do 5.
It's okay, it's fine.
And let's set up 2 angles.
You're really sucking at words right now.
So I'm going to set up an angle on the left.
I didn't say anything.
20.
Sloffer, give me an angle.
39.
Give me something that's nice. and
40.
40, all right.
60.
Here's a 40-degree angle.
I keep dropping
42.
it. Sorry.
Jackie Robinson.
Here's a 40-degree angle.
You smell like urine. Oh my god.
Gentlemen, can you shut up, please? So these are both 40. And now I don't want an angle on either side, right? I want an angle that's not with the side in between. So I'm going to make an angle over here. So give me an angle measure for this guy. 90. All right, so in order to make it a triangle, I have to make sure it intersects. So there's 90. That looks like it's going to hit it at 90, right? So let's see. There's a 90-degree angle. There we go.
That is out about the.
Sorry.
No, that isn't bad actually.
Thank you. And I'm going to make a 90-degree here as well. And again, I have to make sure it intersects so it actually does be a triangle, right? It does be. Because this guy's locked in, I can't make him any longer, right? So there's 90. Does that lock us into one specific triangle?
Yeah.
It does. So it turns out this is also enough to prove it's congruent. So if you know 2 angles and a side, you're good. You also are good if you know 2 angles with a side in between. We proved that earlier, right? So here's what I want you to do. Check the rest of these and see which ones work and which ones do not. I would encourage you not to use 90 degrees for your angles because 90-degree triangles have special properties. I'm going to prove it for any triangle, no matter how weird, okay?
I know that.
Yes, you may. It's not in here.
I have a question.
So now that we know both of these work, we get both of these for free as well, and this. So the real question you need to check are these 2. That is going to be your homework. Does ass work?
No,
Okay, it depends on what you're asking.
I have a question, Mr. How come in the previous years when we like done this,
There's a joke
it's only
here.
when it gives us the triangles, it only gives us 3 options to solve.
They got
Siding, it's like siding.
There's more than that. I don't know why. Your teacher decided to do that. Maybe they thought it was too much for you.
Big joke here.
Doing a warm up.
That's all your homework is going to be. I want you to see if ASS and SAS work.
You say it does. And and then you work on the Rodrigo.
So see if asked works. I mean works.
Tomorrow.
Okay?
What's this tomorrow?
That's it. That's all you have to do.
Oh.
The other classes are going to have questions because your 6th hour, you always get the best show. So encourage them to watch this video since most of you guys, I think, are smelling what I'm stepping in. Also, work together in groups.
This is a video?
Yep, we were doing it live. At least I hope we were doing it live.
Mr. McAnally with the pretzels, oh my god.
No, not me.
You can hear me dropping your phone.
You
I'm serious.
work on your Rodrigo thing and then you talk
What?
about.
If you have questions, ask me now before class is over.
When's class over?
Class is over at 42.
So all we have to solve is
We have
AS
2
and
minutes.
A, that's it? Or is
ASS and SAS. See if that's enough.
Ass.
Ass and sass.
If you're not sure about how to go about doing that on the paper, rewatch the video or ask me a question now.
I have a question.
So let's do 1, 2, 5.
Okay, so I showed, so all I needed was to check if, so I wanted angle, side, angle, meaning that both angles here will be the same, the side in between will be the same, and the angle will be the same. So I just chose a random number to make sure it's
Pick
the
any
same.
number, then
Yeah.
draw the length of it.
Right, they just have to
Give
be
me a
the same.
number. Sure.
Because that's what I'm checking. Angles are kind of weird to check because they don't really have length, right? So be careful. So figure out if ASS works and SAS works.
It's fine. Don't- I'm the one.
Don't assume they do.
You're making an OTV.
Foul.
I
You'd be
hope
very
so.
disappointed.
Can I pass it?
Yes, you may.
Andre. I like this stuff.
So offer your MC, please.
Who
Thank
is
you.
on top?
Can I leave?
Not yet.
Your class.
Where did
You're
all
the
that
honest.
go?
You have a phone? Homeroom. Oh wait, who's gonna put it in
Yeah, we're quiet.
Well, no, he doesn't like having a homeroom.
You guys like to eat your candy canes with the peel or without the peel?
With the peel.
I like the shell. Wait, did he just?
That's how you do it.
I like them.
If
I
I
like
throw
making
peel.
them into pokey things.
I feel like the fiber's good for you.
Don't judge my sins.
Yeah.
Yeah.
Mr.
I like making mine into
Plastic.
pokey
Plastic.
saw.
Like, it's not good for you.
That's not
What are you
big
talking
man.
about?
Do you want it
Kim
back on
Kardashian
Earth?
has them.
Killing sea turtles, or do you want it to actually use
I like
it?
making my candy canes with a chain.
Kim
You
Kardashian.
don't spell your name.
Okay.
Son of a biscuit.
I feel like you really should.
Eating the plastic off.
What about our warm up from last week? I don't know what happened to mine. I'm kind of sad about it. It's not.
I'm at like fight.
Last class of the day, I just want to see.
Oh no, thank you.
Can you deliver that message to her? Shit, unbelievable.
I can't wait to get my
Go away now.
No. I'll
Okay,
leave.
Mr. Mac.
Bye.
Bye, Mac. Have fun.
See you tomorrow.
Have fun eating your plastic.